find the points of inflection. And they've given us the graph of the second derivative. And since we haven't really studied this all that in detail yet, the second derivative, when it is less than 0, the function is concave down. And when the second derivative is greater than 0, it's going to be concave up. So it's going to be concave up here. You can see it right here. Whoops. Let's see if we can do this here. Yeah. Concave up here. It's concave up here. And then it looks like it's going to switch concavity at B, but it never gets past the x-axis, so it always remains positive. So the function remains concave up on those intervals. Well, you can see between A and the origin, this graph looks like it remains concave down on these sections right here. So the definition of a point of inflection is when it switches from concave up to concave down, or from concave down to concave up. So you should be able to figure out from there. Let me just label these here so you hit pause if you'd like to. It's concave down here. The function is concave up here, concave up in this interval, and concave up here. So give it a shot and see what you think. Hit pause if you need to. And let's move on to number 22. Thank you, Lyle. Okay. On number 22, they're asking us to find the equation of, find the value when the function is equal to 1, and they give us the derivative right here, okay? So this is a linear derivative. So if we take the integral of the derivative, it's going to take us back to the function. So, well, we first note that this has an intersection at 0, 6, and then it crosses the x-axis at 1, 0. So its slope would equal what? The slope would equal a negative 6. Rise over run, down 6 over 1. Well, with this information, we can now write the equation of this line. The equation of this line is, this is the derivative now. It's a negative 6x plus 6. So now let's take the integral of this equation, and we get the function itself is equal to what? Negative 6x squared over 2 plus 6x plus some constant. Simplifying that, we get a negative 3x squared plus 6x plus the constant. And then you got to go back up to the original statement, and they give us that when x is 0, y is 5. So we just plug in these values here. 5 equals negative 3 times 0 squared plus 6 times 0 plus the constant, and we see the constant is equal to 5. So we are to now write our equation. Be this over here. Negative 3x squared plus 6x plus 5. Constant equals 5. Okay, so now we just need to go back up and see what point they were looking at. They want us to find the function value of 1. So we have negative 3. And we simply plug in and see what we get. Alright, we should be able to finish that one up. Okay. Let's look at 23. And 23 This is asking us to take the derivative of the integral, but we notice here that this is in terms of t, but they have an x squared in the upper limit there. So you should be thinking, let's use the second fundamental theorem of calculus. Okay, let me give you an example over here. So if we have from 0 to x any function in terms of t, let's say. Sorry about that. So we have like t to the 4th power dt. Well, if you're taking the derivative of this, the shortcut is to just plug in the upper limit into the t, but you have to remember that you're taking the derivative of this upper limit here in terms of x. So the derivative of that is just 1. So just keep that in mind. Notice that this is not just simply x. It's x squared. Alright, so I'll let you take it from there.